Hello, pre-algebra. Mr. Lawrence here with your video, your flipped lesson for the weekend of February 17th to the 20th. This is my pre-algebra class, and today we are going to talk a little bit about volume. Volume. This is more 8th grade level mathematics. Volume. We were used to doing area. Today we are doing volume. Now, let's first of all check out some shapes here. You see this heart? I give my heart to you. That heart has area. It does not have volume. Get out of there. Let me put it over here on the area side. Area. Okay, it has area, not volume. Let me see. How about this pentagon? Pentagon, does it have volume? Nada. It does not. Get over here. Get. There we go. It doesn't have volume. It has area. The star, I know, the star has volume. Wrong again. It does not. It has area. All these shapes have area. I know, a circle. No, circles don't have volume. They have area. Okay, what has volume then? 3D shapes, guys. 3D shapes. So if I have, here, let me just draw freehand. If I have a rectangular prism, a cube, that has volume. If I have a pyramid, pyramids have volume. It's kind of hard to draw. But anyway, cylinders. Cylinders have volume. 3D shape. Volume is the space inside a 3D shape. Volume is the amount of Coke that fits in that bottle you see me drinking every day, the Coke Zero, right? Volume is the amount of air inside a classroom. Volume is like those clowns at the circus. The number of clowns that can fit in the car at the circus, that's the volume. Of course, that's a trick, but that's what volume is. Volume of your shoe is the amount of foot that can fit in the shoe. Volume of a tissue box, number of tissues that can fit in there. All right, now to calculate volume, it's really, really simple. You see, when I see a shape like a rectangular prism, okay, something like that. Can I clone all that? I can. Cool. I love my smart board. It makes drawing 3D so simple. All right. When I see this, you know what I think of it as? I think of it as a whole bunch of rectangles stacked up on top of themselves. Oh, that's not the rectangle I want to stack. Hold on. The rectangle I want to stack is this one right here. And in fact, I'm going to highlight it. This yellow one. Okay. Did you ever see a ream of paper? Picture a single sheet of paper, and then another sheet on top, and 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 another sheet on top. Volume, or a rectangular prism, is like that rectangle and it's drawn kind of like that because of the angle we're looking at. It's not intended to be a parallelogram, it's intended to be a rectangle. And then there's a whole bunch of them stacked up top of each other, like that. Oops. See? And if I stack up enough, you can see I get kind of a box thing going on. Can you see that? Where there's a side, that's the back corner, there's the front corner. And look at that, it looks almost like a building, doesn't it? See, I see prisms like that. Cylinders, I see cylinders as a whole bunch of circles. Okay? I'll infinitely clone it, stacked up on top of each other. Picture some quarters. Just keep stacking more and more quarters up on top of each other. And eventually, if you stack enough, you get a cylinder, don't you? Look at that. It looks like a cylinder, all right? It's going like that. It's going like that. It would be better if you couldn't see through it, but the cylinder, in this case, would look something like this. Well, if you think about 3D shapes in that way, calculating volume is easy. And again, I'm not going to use a whole bunch of different formulas. I'm going to use this formula here, volume. I'm going to use capital B times H, all right? Where capital B is the area of the base. Area of the base. So in a cylinder, the base is a circle. I'll find the area of the base. In a rectangular prism, the base is a rectangle. I'll find the area of that rectangle, and I'll multiply by how tall it is. So let's look at an example here. Let's have a rectangular prism like this. Okay, and I will clone him. You are cloned. Dolly's got nothing on me. No, you guys don't get that joke. Never mind. All right, she was a sheep that got cloned. All right, and I am told that this is 3 inches deep and 10 inches long, and this will be 8 inches tall. All right, well, to do the volume of this rectangular pyramid, or rectangular prism, I'm going to find the area of the base times the height. Well, first thing I'm going to do, I'm going to highlight my base, and my base is going to be this. All right, there's my base. So the area of the base is a rectangle. So I'm going to do 3 inches times 10 inches, and that'll give me the area of the base. Now, how tall is my prism? Well, the height is 8 inches. So I'm going to multiply by 8. Well, that's going to yield an answer of 240 inches cubed. Presto, there's your volume. See how simple that is? All right. Now remember, in class on Friday, I mentioned you're going to need a cereal box. You're going to keep hearing about that. Bring in a cereal box. Let's say this time I have a cylinder. All right. I want to draw a cylinder. And I know that the side of the cylinder is 15 millimeters. All right. I also know that the distance across the cylinder is going to be, oh, let's make it 12 millimeters. Okay? To find the volume, to find out how much water would be fit into that cylinder, I'm going to do the area of the base, and I'm going to multiply it by the height. Well, my base in this case, gee, I'm a poet and I didn't even know it, my base is a circle, right? So, to figure out the area of that base, I'm going to need my formula for the area of a circle, and that'll be pi r squared. So I'm going to need to know the radius. Well, the diameter is 12. That means the radius is 6 millimeters. So I'm going to go 3.14 times 6 millimeters square. And then I'll multiply by how tall it is, and that'll be 15 millimeters. All right. When I get my calculator out, oops, you can't see that. I'm going to multiply 3.14 times 6 squared times 15. And I'll get an answer of 1,000, oh, I'm not in right mode, 1,695 and 6/10 millimeters cubed. Because here I'll get millimeters squared, and then I'll multiply by another millimeters. Millimeters times millimeters times millimeters is millimeters cubed. All right, so we're multiplying the area of the base times the height. That works for rectangular prisms. It can work for a triangular prism, and it can work for a cylinder. Let me try to draw a triangular prism for you so you can see how it works in that situation, and then we'll wrap up this video. All right, so I'm going to have a triangle. Okay, and I'm going to call that a right angle. I know it doesn't exactly look like a right angle, but we're going to call it a right angle so that it makes our math a little easier. I'm going to put this up here, and then I'm going to connect that side to that side, those back sides, and there. All right, now you need some measurements. I'm going to tell you that this is 8 inches. I'm going to tell you that this back one here is 6 inches. And I'm going to tell you that the whole thing is 30 inches tall. All right, well, it's a triangular prism. Now, you know what? How do I know it's a triangular prism? I don't know if you realize this. The bases in prisms are parallel to each other. Yeah, the bases are parallel. And notice in a triangular prism, the only two parallel faces would be the triangles. So I have a triangle highlighted in yellow, and I know that it's 6 inches by 8 inches. Okay, now before Drew tries to tell me that's 48 inches, I'm going to remind him that a triangle is only half of a square rectangle. So the formula for the area of a triangle is base times height, but I got to divide by 2. So it's going to be 8 times 6, but then I'll divide by 2. Okay, now to do the volume, I need the area of the base, multiply the height. Well, this is how I get the area of the base. So I'm going to bring that down here, and then I'm going to multiply by how tall it is, and that's 30 inches. All right, I'll do inside the quantity here, and I'll get 24 times 30, and I know that 24 times 3 is 72, so this is 720. I'm talking volume, it's 3-dimensional, inches cubed, and there you go. All right, Mr. Lawrence signing off. Hope you have a great long weekend. Good night, everybody.